is T119 Algorithms and Programming. Which of the following is an appropriate description concerning a sorting method for data? In a quicksort, a subset of data elements that is retrieved at a set interval are sorted. The interval is then further reduced, and the same operation is performed. This process is repeated until the interval becomes 1. In a heap sort, an unsorted section is configured into an ordered tree, and in this then the greatest value or the lowest value is retrieved and moved to a sorted section. This operation is repeated until the unsorted section becomes progressively smaller. In a bubble sort, an intermediate base value is decided and elements are divided into two groups containing elements with a greater value and elements with a lower value. The same operation is then repeated for each group. In a shell sort, adjacent data elements are compared and they are switched if the order of size is the wrong way round. This operation is then repeated. For sorting methods, as well as the three basic sorting methods of the bubble sort, the selection sort, and the insertion sort, there are applied sorting methods with a reduced volume of calculations, including the quicksort, the shell sort, and the heap sort. Many of the applied sorting methods use recursive algorithms, and it's necessary to understand the basic flow of each algorithm. The heap sort is an improvement on the selection sort. The selection sort is a method that takes the smallest or largest data element from a string of data and makes it the first element, and then from the remaining data string takes the smallest or largest data element and continues this recursive process. A heap sorting method is that based on this selection sort, but uses a tree structure called a heap. Therefore B is the appropriate answer. So let's briefly have a look at the other answers before we look at the heap sort in some more detail. So in A, the description is of a shell sort. A shell sort is a method that is an improvement on the insertion sort. It's a method that retrieves data in a data string at a certain interval or gap and makes it a subset. It then sorts each data string with an insertion sort, reduces the interval further, and sorts the data again. C is a description of a quicksort. So a quicksort is a method that is an improvement on the bubble sort. It is a method that sorts by repeatedly retrieving a single element of data for comparison, and then dividing the data into two groups, one with a group of a lower value than that element of data, and one with a group that is higher value than that element of data. Description D is of a bubble sort. A bubble sort, or an exchange sort, is a method that compares adjacent elements of data and swaps these elements of data if the order of size is the wrong way around. So therefore our answer is B. And in this video we've learned to look at the different types of sorting algorithms there are out there. What we're now going to do is take a more detailed look at our answer B, which was the heap sort. So a heap is a binary tree that has a special structure compared to a simple binary tree. In a heap, the root element is greater than any other element of data in the subtree. The root element is the largest element. It uses less resources than a BST and can be handled easier and faster than a BST. It's a complete tree. The maximum complexity is log n, so all operations can be performed in O log n. Or can be performed using the following steps. Firstly, create a heap using the provided data. Second, remove largest element from the heap. 3. Reorganize the heap with remaining data elements. Step 2 and 3 are repeated until all the elements are traversed. So to make a heap, an algorithm is used that works in a bottom-up manner and works its way towards the root. This is how the algorithm works. First of all, traverse from the lowest right parent, non-leaf, and proceed left. When one level is complete, start again from right on the next level. At each node, prelocate down each element to its proper position in the subtree, or the subheap. Okay, so here is a graphical illustration of how a heap can be sorted. So here we've got our binary tree, and it's our special sort that we're going to be using to confirm and move numbers to be in a correct order. So first of all, what we do is we look at the right hand tree. And so what we do is we look over here. So this has been highlighted down here, and what we do is start at 5. It is larger than all the values in the subtree, so it is okay and in the right position. So we move on to the next tree, and we move over to here. So here what we're going to do is we're going to again compare this set of data, and this is showed on the next slide, and we'll go through in a bit more detail. But just as we can see, what we can see is 4 is going to be larger than 1. So we're going to swap the 4 and the 1 to go in that order. So here what we can see is our 4 and 1 have been swapped, and that's shown here in this fixed 1. Our new table of data looks like so. And now we move on to the top root. So here we're looking at this set of data, the highlighted data here. And what we can see is that 5 is not smaller than any of the children, so it is okay. So this completes our heap sort details.